Welcome, my fabulous chemistry students. Video number 4, balancing chemical equations. We will apply the law of conservation of mass, which states that matter cannot be created or destroyed, to balanced chemical equations, and that's what will actually, of course, make them balanced. Oh yeah, I just said all this in that last slide, didn't I? All right, so first, chemical equations. We need to understand that reactants are on the left and products are on the right. Okay, the reactants are going to react. Okay, and that's what this symbol means, basically. Become or go into. So my reactants on the left are going to combine together to make a product. What we need to do is do inventory to make sure that the number of atoms on the left are the same as the number of atoms on the right. Here we go. So chemical equations, of course, must be balanced. I think of the arrow as an equal sign, even though it really isn't. The law of conservation of mass states matter can neither be created nor destroyed in a chemical reaction. I cannot create carbon, but I can transfer carbon or change the state that it's in. Okay, balanced equations. So the number of moles of each element on the reactant side must be equal to the number of moles of the element on the product side. Basically, inventory. What we're going to use is the coefficient subscripts to tell us how many of each that we have. So here we go. It says, look at this balanced chemical equation. It's balanced. On the left, I have one carbon, and I have one carbon. I have two oxygens. I have two oxygens. So neither was created nor destroyed. In this chemical equation, though, I have two hydrogens on the left, and I have two on the right. I have two oxygens on the left and only one on the right. So does that going to violate the conservation of mass? Well, yes, because I will have to have destroyed an oxygen atom. Where is it? Where did it go? I don't see it. Coefficients are going to be the numbers in front of our atoms, just like in math class, that we would distribute. Coefficients will be distributed to all atoms in the compound. Subscripts are within a compound that we're pretty familiar with that tells us how many atoms of a particular kind there are directly in front of the subscript. Unless, of course, it's a polyatomic in its parentheses, then it's the whole polyatomic. You will hear me use species a lot, especially when we get into bigger molecules. I will just term any reactant or product as a species if it's a single piece that's either a reactant or a product. Okay? So, what do we use to balance is coefficients, and this is the truth right here. We will never, ever, ever use subscripts because that's going to change what it is. So if you just look here real quick, I have Ag2S. Well, AgS is not the same thing. And AgS2 is not the same thing. So if I were to try to use subscripts, that's going to change what's going on, and it breaks the rules. I know some of us like to break more rules than others. First step, let's look at coefficients within this whole chemical equation. The coefficient in front of Ag is 2. The coefficient that is not there in front of S is 1. The coefficient that is in front of Ag2S is also 1. Remember, when we don't see a number in chemistry, we assume it's a 1. So I'm going to switch colors. We'll do subscripts in green. Again, no number there. I will assume it's a 1 for Ag. No number behind the S, so I'll assume it's a 1. The subscript for this whole molecule is 1, but that's not, it doesn't ask us for that, right? It just says what's the subscript on Ag, which is 2. The subscript on sulfur, 1. Okay, real quick review of subscripts and coefficients. And now on to the meat and potatoes of the lesson, balancing equations. Here's a bunch of steps. I do want you to read them through. I will tell you that Mr. Monaco and I have slightly different interpretations of this, and I'm going to model for you how to do balancing equations, and you're going to just basically follow how I tell you to do it, and you're going to do it. It's going to be fun, yay. I call it the ping pong method. So what we need to do basically is take inventory, and it works very much if you ever like worked at Wegmans or something. You got a whole bunch of cereal on the shelf. Well, you need to know how many Cheerios you sold so you know how many boxes of cereals to bring out. You always want to keep it full, right? Well, this is going to work very much the same way. I do something called the ping pong method. We're going to go back and forth, left to right and left to right till we finish this and everything's all balanced. So what I want you to do is step number one. I want you to write down the elements right underneath the arrow that we have. I have hydrogen and I have oxygen here. Next step, let's take an inventory. I need to count how many hydrogens on the left. 2. How many oxygens on the left? 2. Now let's do the right-hand side. How many hydrogens? 2. How many oxygens? 1. Now this is where we compare. Hydrogens are balanced, but oxygen isn't. So what do I have to multiply this 1 on the right by to get to 2? Well, 1 times 2. I can add coefficients, so let me add that coefficient number 2 in there. But now I have to reevaluate, and this is the piece that you can't forget. So now I have to do the whole molecule. 2 times 2 for hydrogen is now 4. I can cross it out and write my new number. 2 times the 1 oxygen in the molecule becomes 2. Now reevaluate. I have 2 oxygens on both sides. I'm good. But hydrogen is not, I messed hydrogen all up. So now I got a balance on the left side. So we're going to go back and forth and back and forth. We can call this our net, if you will, if we're going to play tennis, right? So what am I going to multiply 2 by to get 4? Well, 2. 2 times 2 is 4. I reevaluate. I now have 4 hydrogens on both sides. Check. I'm balanced. Now I'm going to tell you on the first time through, there are 2 major multiple choice questions you're going to run into, and they're going to be one of these 2 varieties. Here's the first one. It's going to say when this equation is correctly balanced, what is the coefficient in front of hydrogen? Well, so we just did this and we figured it out that it's 2, and so you would pick 2. Now there's one other tricky question that I'm going to tell you right now so we don't get caught up. It's going to say once this equation is properly balanced, what is the sum of the coefficients? And if you leave it just how it is looking at it, you might pick 4. Oh, and wonderful. And you know 4 is going to be an answer choice. But what you need to know is that there's a 1 there, and I'm going to ask you to put those ones in. So now the total sum of the coefficients now is 5. Okay? So sorry about the bells. I'm going to keep going through this and try and make this a not 16-minute-er. I'm going to skip this one. Let me just set it up for you. I have Na, I have H, and I have O. The hint I'll give you on both of these is if you can leave H and O for last because they're diatomic, that's what you want to do. I'm going to move on to this one, and it's semi-complicated because there's oxygen in all 4 species. Makes it slightly, potentially hairy, if you will. But let's go ahead and start, make our net. I have carbon, I have oxygen, I have hydrogen, and I have oxygen. So I'm just going to leave it like that. Let's start taking inventory. Carbon's on the left, I got 1. Oxygen's total on the left, I have 1, 2, 3. Hydrogen's on the left, I have 2. Carbon's on the left, I have 6. Oxygen's, I have 6 plus 2 is 8. Hydrogens, I have 12. Okay, so I see all 3 are not balanced. We have to tackle this. There's really no rhyme or reason to which one you start with. My advice to you from doing as many of these as I have, let's save oxygen till last, so hopefully we can get that to just be, let me put a coefficient in front of O2 and we're all set. So that's what we're hoping is going to happen. So let's do carbon first. What am I going to multiply 1 by to get to 6? Well, I need to multiply it by 6. Let's reevaluate. I have 6 carbons now. Now I have 12 plus 1 oxygen is 13. Okay, see how we did that? I have 6 times 2 is 12, plus this one other one over here is 13. Okay? So now what do I want to take next? Remember, I want to save oxygen for last. So let's do hydrogen. I have 2 of them on the left. I need 12, so I need to multiply by 6. 6 times 2, reevaluate, is my 12. Now reevaluate all the oxygens. I have 6 times 2 is 12 on this side. I have 6 times 1 is 6. 12 and 6 is now 18 I've gone to. So everything is balanced on as far as the carbons go and the hydrogens go. I just need to balance my oxygens. We're all set. I need 18 total. Okay, so do I want this number to be 18 oxygens? Well, no, because of this here. So if I have 6 plus what number equals 18? Well, that's going to be 12. 6 plus 12 is 18, correct? So I need this to be 12 oxygens. So that's going to be a 6. 6 times 2 is 12, plus 6 is 18. Sorry about the bells, but now we're balanced. Bam! Don't forget we got to put a 1 in here in case, oops, where'd it go? A 1 in there. And I'd like you to actually use the ones for now until we get really, really good at these so we don't get caught on one of those problems. All right, the last piece to these, and there's plenty of practice, I promise you this is going to take a lot of practice to get real good at it, is polyatomic ions. I'm going to tell you right now, treat them as a single element if they're on both sides. I have an SO4 on this side, I have an SO4 on this side, even though it's not in parentheses. So I can do it. I have OH on this side, I have OH on this side. So we're good. I know I'm going fast, but the first time I did this video was 16 minutes, and I'm trying to keep it down there. So let me set this one up for you and see how we do. I have aluminum. I have SO4, sulfate. I have calcium. I have hydroxide on both sides, so I'm good. Let's go ahead and start. I have aluminum. I have 2 on this side. I have 1 on the right. Sulfate. I have 3 on the left. I have 1 on the right. Calcium, I have 1 on the left, I have 1 on the right. Hydroxides, 2 on the left, 3 on the right. So let's start right in with aluminum. 1 times 2 is 2, so it gives me 2 aluminums, but it gives me 6 hydroxides right off the bat. Let's go on to SO4. I have 3 on the left, so 1 times what is 3? That'll be 3. Reevaluate, I have 3 calciums now, and I'm going to have 3 sulfates. I might have said sulfur earlier because I am kind of rushing to get us through this video so it doesn't take all of your day. Now I need to do either the calcium or the hydroxide. Let me just do the calcium and see how it works. 1 times what is 3? That'll be 3. Reevaluate, 3 times, that's 3 calciums. 3 times 2 is 6 hydrates. 2 to 2, 3 to 3, 3 to 3, 6 to 6, check, 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 check. I am balanced. Don't forget to put our 1 in there, and we are done. That's how we do it. So we need to move on to practice packet. You can do pages 11 through 14. There's a lot of it. You need to do it. The balancing EQs in the castle, don't forget that. You're going to find that those questions are going to, you might catch some of the variety that I mentioned. And I've shaved a bunch of minutes off that 16 minutes, so you welcome. I'm posting it.